Good morning, everyone. I welcome you all to today's discussion. Um, Today we are going to look at the Slusky equation. Actually, anybody who has done basic economics will know that we always have the law that states that all things being equal, when there is a change in price, it also results in a change in quantity demanded. But have you ever asked yourself why anytime that there is a change in price, all things being equal, it also leads to a change in quantity demanded or your quantity that you consume? Great. So in economics, we always say that we have some reasons supporting that. For instance, it can be as a result of substitution effect. That is when the price of a commodity changes. Let's say it decreases. It becomes cheaper relative to its substitutes, right? Let's say, for instance, you have your Milo and your Bonvita, and the price of Milo has gone down. Now, when the price of Milo goes down, it becomes cheaper relative to that of Bonvita. So you end up having those who are consuming, you have some of those who are consuming Bonvita shifting toward your Milo. That is one reason why all things being equal, your quantity for the Milo will increase. On a second, another one is also as a result of your income, that we say real income. When the prices of Milo goes down, your real income increases, and now because your real income increases, you have the capacity to buy more of the commodity, right? And as a result, you increase your consumption of what Milo. Now, what this Lasky equation seeks to do is to decompose the effect or the total effect of changing price into the substitution and the income effect. So basically, that is what the Slusky equation does. There is a change in price of your commodity, and you are saying that the change is coming as a result of two main things: substitution effect and your income effect, right? So if let's say the price of, let's say, tomato was 2, and you purchased 10, right? And the price of tomato has decreased to, let's say, 1, and you are now purchasing quantity of, let's say, 20. So the change in quantity, which is what? 20 minus 10, which is 10, is coming as a result of what? Your income effect and the substitution effect, right? So what we are going to do is just to decompose the effect of price change into the income effect and the substitution effect. And when there's time, you will also look at the normal, inferior, and the given goods, right? So I'll start. If you remember what we did in our previous discussion, we said from our identities, we said the Hessian that you saw, Hessian demand function, is always equals to what? Let's say you have your commodity I. It's always equals to your Marshallian demand function. That is the optimal x1, x2 that you obtain by using the expenditure approach. Is the same as the Marshallian demand function, right? The optimal x that you also obtain by using the direct utility approach is okay. So this is the identity that we got in our previous discussion, right? Now this one, if you remember, we said always your expenditure, right, should be equal to your income, because you cannot spend more than your income. So your expense should be equal to your income. If that is the case, then we can replace this y with what? EPU, so that I can say x, which is the Hessian demand PU, should be equal to x Marshallian, which is a function of P, and then instead of y, I will write EPU, right? So this is the identities. This is one of the identities, right? So this is the commodity XI. So let's suppose there is a change. Suppose there's a change in price of J. Then if there's a change in price of J, what is going to be the impact of this change in price of J on commodity XI? Is okay. So that will mean in mathematics, we say we differentiate this respect to price of J. So that means I'll have to differentiate XI, Hessian demand function, with the function of P and U with respect to what? Price of J. In mathematics, whatever you do for the left hand side, you do same for the right hand side, right? Now when I come here, I have the P to be here and also here, right? P to be here and also here. So if I'm going to differentiate respect to this one, I can have differentiate x with the function of p, e, p, u, right? Respect to, this is xi, respect to price of j. Is okay? Great. So I have differentiated first respect to this p. Now I also want to differentiate respect to this p here plus. Now look at something. This p here is a function of another function, right? Because this whole expression represents what? Y. It's okay. Now, so what it means, before I can differentiate this respect to b, then I'll have to differentiate this whole x respect to what? Y first. So I have differentiate x respect to y. This x, which is a function of p, then e, pu, right? Multiply by, then I can differentiate this e, this whole e, with respect to what? P. Is okay. And this e is also a function of what? EPU. Is okay. Now great. Then I'll have it as, then I can have it, then I can rearrange it and have it as the XH, differentiate SH, which is a function of P and U respect to PJ, is equals to differentiate XI, which is a function of P, E, P, and U respect to PJ, plus when I differentiated XI, P, E, P, and U respect to Y, then differentiate the expenditure function with respect to U, respect to what? P of J, right? Now this expression is the same as Y, right? So this expression is the same as Y, so that is why I didn't write the Y, so I have to write this, right? Now look at something. Now if you remember from our Shepherd, when we did expenditure function, we said by the Shepherd lemma argument, by Shepherd lemma, if you differentiate E respect to P of J, then that's the same as what? X Hessian of J, which is function of P and U, right? We did this in our previous discussion that anytime when we did expenditure function, that anytime that you differentiate the expenditure function respect to price, then it gives you the Hessian demand function for that. It gives you the Hessian demand function for what you differentiate respect to. So in this case, when I differentiate respect to price of J, it is giving me the Hessian demand function for commodity J. Is okay. So what it means is that in place of this expression, I can write this. In place of this expression, I can write XD, right? Then I'll have it as differentiate XH P of U respect to P of J is equals to differentiate XI P E P of U respect to PJ, right? Plus X Hessian of J P of U multiplied by differentiate X I with the function of what? P E P of U dy. Great. So now we have this expression. We have it as this, right? Great. So wherever I see EP of U, I can now replace it with what? My Y. So let's go back. So I will say differentiate X Hessian with the function of P or U all over P of J is equals to, let me check it again, is equals to differentiate, is equals to differentiate X I P, what was a expenditure function P of U, but I will write it Y because we agree that expenditure is the same as what? Your income. Then the P, the PJ, right? Plus X Hessian of I P of U, then multiply by differentiate xi P. Then instead of writing EP expenditure function, I'll write Y all over the Y. Great. Now look at so from identities, we said X fixing of what? P of U is equals to X is equals to so this is J, not I, is equals to X Hicksian, sorry, X Marshallian of what? P and Y. That is what we say from our identities. So that means I can replace this expression here with respect to what? X, P, and Y, right? S with the function of P and Y. That means I'll have my differentiate SH respect to P of U respect to PJ is equals to differentiate XI with the function of P and Y dPJ plus XJ with the function of P and then Y multiplied by differentiate X with the function of P and Y all over the Y, which is respect to income. Great. Now we have this. So I can decide to make this expression the subject, right? I want to make this expression the subject. So I will have it as differentiate X. Then I will have it as differentiate XI respect to P of Y. The PJ is equals to differentiate X, which is a Xi, which is a Hicksian demand function, P of U, the PJ minus XD, which is a function of P and Y, differentiate X, differentiate XI, which is a function of P and then Y, respect to income, right? So this is what we termed as what the Slusky equation. So this expression here is the same as slope of the demand curve. Slope of demand curve. This expression here is the same as what? The slope of Hicksian demand. Slope of the Hicksian demand curve. Slope of the Hicksian demand. And this expression here is looking at the effect of change in income on the commodity that you are going to consume. So this is looking at, so when you increase your income by, let's say, $1, you are likely to increase your consumption of XI also by that amount. Is okay? Great. So that's what we are going to look at here. Now, our interest is in this one. So this is what we call the total effect. So the total effect of change of price is equals to the substitution effect here, right? And this one is minus SD multiplied by the income effect. Great, is okay. So in this case, I can say the total effect here, the Xij, is equals to Sij minus Sj multiplied by income effect. I'll just say IE and then I given Y is okay. I'm just going to use this to represent that. Great. So what we are now going, so this is what we call the Slusky, this is what we call the Slusky equation, right? This expression here is what we call the Slusky equation. Now, so let's look at something. This is looking at a situation whereby there's the XI, the PJ. That is what happens to the commodity I when price they change. That is, you have, let's say I equals to price 1. I'm just assuming that I equals to 1. And let's say J equals to what? 2. So then the XI, the J. Then what it means that the XI the P of J is the same as differentiating X1 respect to P of what? Price of 2. So what it means is that what happens to commodity S1 when price 2 or changes. So supposing you solve for the Slusky equation and you end up having the Xi, the Pj, which in this case I'm using 1 and 2, greater than 0 is okay. Then what it means is that so let's say the X1, the P2 is greater than 0. Then what it means is that when your price of commodity 2 goes up, is okay. It implies commodity X1 will also go up, right? But ideally, price of 2 goes up and you are consuming more of what S1. Then what it means is that they are what? They are substitutes. They are what we call it gross substitute because price of 2 has gone up. It is now what? Expensive. So you are replacing it with commodity X1. That is why you are consuming more of what? X1. So when you solve this last thing, the total effect, that is the Xi, the Pj is greater than 0, then we say it is the same as what? Gross substitutes. Gross substitute. Is it okay? Gross substitute. But the situation where you solve the Xi, the Pj, and it is what? Less than 0. What it means is that the relationship is negative. When price of J goes up, implies the consumption of what? X1 comes down. And this can only happen when they are what? They are complement. That means in situation like this too, when you have the SI, the PJ to be less than 0, that means they are complement, right? Complement. They are complement. The complementary goods. That is because price 2 has gone up. People are now consuming less of what consumption. I remember in those days in the senior high school, I remember one lecturer of mine or one teacher, he always used torchlight and battery to do this explanation. So he always goes like, let's say you used torchlight and then battery jointly, right? And because of that, the price of battery has gone up. Now the price of battery goes up, then you are going to reduce the number of torches that you are going to buy. It's okay. So that exhibits the negative relationship. Price D goes up, X1 also goes down, right? So this is the situation whereby we are looking at what happens to a certain commodity when the price of another commodity changes. Is okay. From the same using the Slusky, there's a change in price of commodity. Let's say 2. What is going to be the effect on commodity 1, right? And we are saying that if price of 2 goes up and you end up having commodity 1 increasing your consumption of commodity 1, then it means then commodity 2 and then commodity 1 are what? They are substitutes. But if the price of 2 goes up and you end up reducing your consumption of commodity 1, then we say they are what? Complementary goods. Is okay. So this is what happens when there's a change in price of one commodity on another one. But let's look at when there's a change in the commodity itself, right? So the same Slusky that we wrote it as the Xi of the PJ, right? But in this case, I'm writing that the SI, the SI, the PJ, we said is equals to differentiate the hexane demand respect to what? PJ plus, this is Xi, right? Plus SG into bracket differentiate I respect to what? Income. So let's look at, in this case, we looked at a situation whereby there's a change in what? PJ rather. But we're looking at a situation where there's a change in the price of the commodity, the price of the commodity itself. So let's say instead of, if I is tomato and the J is pepper, we're looking at the effect of change in price of pepper on that of tomato. But in this case, we are going to look at the change in price of tomato itself, right? So we will give the Xi, H, the PJ. Sorry, this is supposed to be minus. Yeah, this is supposed to be minus. Minus SG. So this is going to be minus Xi, the Xi, the Y, right? So now look at something. You're looking at what happens to the price of what happens to the quantity of commodity if its own price changes, right? But this is what we call the substitution effect, right? And this side is what we call the income effect. Always the substitution effect is sort of negative. It is always negative because if the price of the commodity itself changes, you reduce the quantity you are consuming. So the substitution effect is always negative, right? But the income effect here, it is going to depend on the income effect here is going to depend on whether the commodity is a normal or what normal of a given goods is okay. So let's say you saw. So let's say if the commodity is a normal good, it's okay. So let's say if the commodity is a normal good. Now, if commodity is a normal good, commodity is normal. If commodity is normal good, then the income effect is positive. That is, differentiate S respect to Y is what? Greater than 0. It's positive because when your income goes up, you consume more of that commodity if it is a normal good, right? So that means the total effect, this, using the Slusky equation again, the SI, the PI, which is now equals to the substitution effect, right? Which we know to be negative, right? Minus SD, right? Multiplied by the income effect, right? Now you know because it is a normal good, the income effect is also negative, right? Sorry, because it's normal good, the income effect is positive. If it's a normal good, the income effect is positive, right? So this is minus plus. Minus, when minus and plus means we have minus, right? So if it's a normal good, then the XI is always going to be less than 0. It's okay. Because if it is a normal good, the income effect is positive, right? Substitution effect is negative. But because there is a minus here, we have here to this expression, whole expression to what? Negative. So negative means it's less than 0, right? Because it's negative minus negative. If you have minus 2, minus 1, you have it at that source, something that to be less than 0. So what it means is that when you have a good that is normal, when you have a normal good, that when we say it is normal, that is when the income increases, you also increase your consumption of that commodity, right? So when you have a normal good, then anytime that there's a change in the price of that commodity, then that is if the price of that commodity goes up, the quantity will go down. And if the price of that commodity goes down, price of the normal good go down, the quantity will also go up. So that exhibits the negative relationship. So the relationship is negative. That's why I say it's less than 0. So the less than 0 is talking about the relationship between the price and the quantity. When price goes up, you consume less for a normal good. And that is the same as what we say about the normal demand curve, right? Now let's look at the situation whereby the commodity is inferior, right? Now, if the commodity is inferior, what does it mean? It means the income effect is what? Negative. So that is the X, the Y is less than what? 0, right? If it is normal, the X, the Y is what? Greater than 0. But if it's inferior, the X, the Y is less than 0. So let's go back to the Slusky equation again. So you wrote the Slusky equation about the XI, the PI is equals to differentiate X, Higgs-and demand function, respect to PI minus SI, the XI, respect to what? Income, right? So we know that the substitution effect is always negative, right? The substitution, the own substitution effect is what? Negative, right? Great. This is minus, right? But this expression is plus, it doesn't matter. And you're saying that the income effect is what? The income effect is what? Also negative because it's what? Inferior commodity. So the income effect is what? Negative. So negative here gives you what? Positive. So we have the substitution effect where is negative and what? The income effect where is positive. So that means the total effect on what? The SI, the PI, which is equals to minus and plus means equals to what? Ambiguous. In this case, it's ambiguous. So you cannot determine. So the impact is at the end of the day going to determine by what? The relative or the magnitude of the substitution effect and the income effect, right? So if the situation where if the substitution effect outweighs the income effect, if substitution effect outweighs the income effect, then the total effect, which is the SI, the PI, is going to be what? Less than 0, right? The total effect will be less than 0. That is if the substitution effect outweighs the income effect, right? Now, if the income effect also outweighs the substitution effect, if the income effect also outweighs the substitution effect, right, then the total effect is going to be what? Greater than 0, positive. The total effect is going to be greater than 0, which is positive. And then in such situation, the second scenario, when the income effect outweighs the substitution effect, which gives you the SI, the PI, with the total effect to be greater than 0, is what we term as the given goods. Okay, so the situation where the commodity is inferior commodity, and you end up having the income effect outweighing the substitution effect, you call it what? The given goods. So what that expression means is that when the SI goes, the PI is greater than 0. In the case of what given good, that means when price of commodity 1 goes up, people end up consuming more of that commodity 1. It's okay. And if the price of the commodity 1 goes down, people end up consuming less of that commodity 1. This is a special scenario in this case, right? So that is also termed as the given goods. Is okay. So that is why in economics we always say that all given goods are inferior goods, but not all inferior goods are given goods. That's the term that. So this explains the reason why we always say that all given goods are inferior goods, but not all inferior goods are given goods. Thank you. Do not forget to subscribe to my channel.